In this video we're going to look at how to solve trigonometric identities, and in this topic what we're looking to do is to either prove the left hand side is equal to the right hand side, or that the right hand side is equal to the left hand side. And for the scope of C2 there are two identities that it's useful to know. The first identity that's useful to know is that tan of theta is equal to sine of theta over cosine theta, and the second one is that sine squared theta added to cosine squared theta is equal to 1. And you are expected to know both of these, and we could go into why these two identities are true, but we're not going to have time for that in this video. So we're going to try and prove that the left hand side is equal to the right hand side. So to start with, I'm going to expand those brackets. So I'm just going to record that I'm working from the left hand side. So if I expand those brackets, I will get sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. And then I'm going to write the sine squared theta and the cosine squared theta together, and then I'm going to keep the other term as it is for now. Now sine squared theta plus cosine squared theta is equal to 1, which is using this identity over here. So 2 lots of 1 plus 2 sine theta cosine theta. So that's 2 plus 4 sine theta cosine theta, and then left hand side equals right hand side. So I've shown that I have manipulated the left hand side into the form where it is on the right hand side. Okay, so this second example, we're trying to show that tan x plus 1 over tan x is equivalent to 1 over sine x cos x. So the fact that this is given in terms of tan and this is given in terms of sine and cosine suggests that we're going to have to use the identity that tan x is equal to sine x over cos x. So tan x can be rewritten as sine x over cos x, and then 1 over tan x is the reciprocal of tan x, so that must therefore be cos x over sine x. I should have probably written that I'm working from the left hand side here. Okay, so what I'm going to do now is I'm going to try and add these two fractions, as here we've got two terms and here we've got a single term. So how are we going to add these two fractions? Well, we need a common denominator. So I'm going to multiply top and bottom of this fraction by sine x and top and bottom of this fraction by cosine x. So that will give me sine squared x over sine x cos x, add cosine squared x over sine x cos x, and I can now add those two fractions. So I've now got sine squared x plus cosine squared x over sine x cos x, and then I can use the identity sine squared x plus cosine squared x is equal to 1, so I get 1 over sine x cos x, and that is what I was trying to show on the right hand side. So I can now say that the left hand side is equal to the right hand side.